Good morning, and welcome to our last section for Chapter 4, which is inverses of linear functions. An inverse relation is the set of ordered pairs obtained by exchanging the x and the y coordinate. So if I gave you a function and I asked you to form the inverse, all you're going to do is switch the x and the y. The domain becomes the range becomes the domain. So that's a good thing if you want to highlight it so you have it for you. And we're going to look at a couple of examples. There are only a few things I would hold you responsible for. So if this were the relation here, -2, -10, -1, -7, 0, -4, 1, -1, 2, 2, 3, 5, and 4, 8, and I said find the inverse. To find the inverse, we're going to flip or exchange each x and y. We're going to flip or exchange each x or y. So the first ordered pair would become -10, 2, -7, -1, -4, 0, -1, 1, 2, 2. It's the same coordinates. Obviously, when you flip them, it doesn't make a difference. 5, 3, and 8, 4. So if they asked you guys to go ahead and graph the given relation and then to graph the inverse, that's what it would look like. However, I'm not holding you responsible for that. The questions on this part of the test will be multiple choice in nature, as will those questions on positive, negative, and no correlation. But I'm cautioning you to make sure you read all of the multiple choice answers. And the reason that's important is you might pick the one, oh yeah, it's positive correlation, and you pick the first one that says positive, but you have to make sure that it agrees with what the graph is showing. So as the years go by, the number of people that got direct deposit checking increased. So make sure you read each. Yes?
Is it possible for us to have a graph that says a positive correlation with an inverse relation? Like one graph has...
Yeah, but I'm not asking that. Okay. All right. So if I asked you in number 1, let's go ahead and find the inverse of relation of number 1. Let's do number 1 and number 3 real quickly. The inverse. Let's form the inverse of each of these. Okay, everybody has it? So basically the inverse of number 1, again you're switching the x and y, would be 7, 4, 2, 6, -1, 9, 3, 11. Does anybody have a question? And the inverse on number 3 would be -15, -8, -11, -2, -8, 1, 1, 5, 8, 11. Are there any questions? Hello? Okay, we're not dealing with the second part where we're taking an equation and finding the inverse. That's more of an algebra 2 type of a question. So again, the inverse of a relation is formed by switching the x and the y coordinate. All right, have a great day, TKA.